In this lesson, we'll look at what's required to populate a table view. UIKit provides a protocol called UI Table View Data Source, and as you can infer from the name, this is the object that provides the source of data for our table. Since our music list controller extends from UI Table View Controller, we don't need to explicitly adopt this protocol as UI Table View Controller does this for us, but we do need to implement a couple of its methods. Let's start by looking at the definition of UI Table View Data Source. As you can see, UI Table View Data Source defines both required methods as well as optional methods. In our required section, we have this table view number of rows in section method and table view cell for row at index path. Since these are required methods, we have to implement these or our code simply won't compile. There are also quite a few optional methods as well, and these are used for editing row data or moving or reordering row data. So we can implement those if we want to, but we minimally have to implement the required methods. Let me switch back to the music list view controller. Now the view controller already provides stubbed out versions of these methods, but let's implement them correctly. Now the first thing we need to do is define a property to hold our data. Let's define a private property in a class extension. I'll scroll up to the top and we'll see this at interface section. And this kind of looks like we have in our .h file, but slightly different in that we just have a set of empty parens here at the end. And this is what's called a class extension. And a class extension allows us to extend the definition of a class interface. This extension is usually done inside of our .m file so that it won't be imported by other classes, which effectively makes it private. Objective-C doesn't truly support the notion of private the way that other languages do. But by reducing the visibility to any properties and methods we define, we're effectively making it private. So I'm going to define a property here. I'll make it non-atomic, strong, and I will make this an NS-mutable array, and I'll call it albums. Because I've defined this property in this class extension, we can see that we're getting a compiler warning because I haven't yet synthesized this property. So let's do that. All right, and the compiler is happy again. Now, as our list can change while running the app, we'll initialize the albums property in the viewWillAppear method. This way, every time the view appears on screen, we can grab the latest state of our music list. So let me import the album class. And I will override the viewWillAppear method. Call a superclass version of this. So I'll say self.albums is equal to, let's create a new NS-mutable array. And we'll call the array with array method. And our source array is going to be album find all. But why did I wrap the return value of the albums find all call inside of a mutable array? Well, the albums find all call simply returns an NS array, not a mutable variant of that. Since we are going to need to manipulate the contents of this array, we need to wrap this in a mutable array. All right, so let's scroll down and look at our table view data source methods. The first one is table view number of rows in section. So this will get called when our table view is loaded, and it's used to determine how many rows of content our table view will have. So our implementation is actually pretty simple. We simply want to return self.albums.count. So however many albums we currently have saved in our list is what we want to return from this method. Next, we'll move on to the table view cell for row at index path method. And immediately prior to rendering a given row, this method will be invoked. Now we're defining the cell identifier value, and we're asking the table view to dequeue a reusable cell with identifier. If you'll recall, a table view cell is the component we use to actually render a row of data on screen. Now, because our table view could have hundreds or potentially thousands of rows, we wouldn't want to create a separate instance of a table view cell to render all of those rows. Instead, table view is smart enough to create a small pool of them and then cache and reuse them. So this is what we're saying here, is we're saying dequeue a reusable version of this cell. Before we proceed, we first want to check if the cell is currently nil. And if it is nil, let's initialize a new cell. And I want to use this initWithStyle method. A table view has got a number of different styles it supports. And the style that we'll use in this case is going to be UI table view cell style default. And this will allow us to place an image on the row as well as a text string as well. And for the reuse identifier, we want to pass in our cell identifier. Now that we have a cell, we can populate the contents of it. Let me first create a variable to hold a reference to our album. And I'm going to say self albums and ask for the object at indexPath.row. So an argument passed to this method is this thing called an index path. And from the index path, we can query for the current row it's iterating through. And this will allow us to get a handle to our album instance. Now that we have an album, we can populate the various properties on the cell. So I will set the image property on its image view and set that to its album image. And on its text label, I will set the text to be equal to our album's album name. So we've dequeued a cell from the table view. If it was nil, we'll create a new instance. We then get a reference to our album, set the various cell properties, and then finally return the cell. Let me run the app and click View List. Well, this doesn't look any different than it did before. Well, that's because we don't currently have any data in our data store. But while I was away, I added this handy feature into our About Music controller that will populate our data store with some sample data. So I'll click the Delete and Reset Sample Data button and click Done and click View List again. And ta-da! We now have a list full of albums. So I can scroll through the albums and we can see that we have our image that we set as well as the text string, which is the album name. And I've just added a few of my favorite rock albums. So we've accomplished a lot in this lesson. We created a class extension to define our albums property, initialized that property in ViewWillAppear, and implemented our key UI table view data source methods. And now we have our list being properly presented in the UI. You should now have a good understanding of how to implement the required UI table view data source methods.